Using the stuff we've introduced so far, basic data types and containers, control flow, loops, allows us to make quite a few simple programs. In this chapter, we will learn how to make our programs more interactive. For that, we need an option to read data from a file or ask a user for an input. Perfect. Reading from a file. Let's say we have a text file called people.txt. In the same directory as our nim code, the contents of that file look like this. Okay, we have just 3 lines with 3 different names. We want to use the contents of that file in our program as a list sequence of names. Okay, so we can import the string utils and say let contents is literally read file people.txt. To read contents of files, we use the read file procedure and we provide a path to the file from which to read. If the file is in the same directory as our nim program, providing a file name is enough. The result is a multi-line string. Okay, that is, I must say, that is extremely simple. Is it in string utils? I don't think so. Let people contents.split lines and echo people. That's it. To split a multi-line string into a sequence of strings, each string containing all the contents of a single file, we use split lines from the string utils module. Hey, this is, wow, basically 2 lines to do this stuff. I really like it. I'm surprised that we don't have to import anything to read a file. Okay, yeah, we'll basically put the contents as a multi-line string and then return a sequence of each line. And here, yeah, I see. So look, here we have extra empty line and here we have extra empty little thingy. So here, there was a final new line, empty last line in the original file, which is also present here. And here, because of the final new line, our sequence is longer than we expected or wanted. To solve this problem of a final new line, we can use the strip procedure from string utils. After we have read from a file, all this does is remove any so-called white space from the start and end of our string. White space is simply any character that makes some space, new lines, spaces, tabs, etc. So yeah, we just read the file and call strip on it. That's it. And we don't have that problem anymore. Very simple. Okay, that's it when it comes to reading files. Let's move to reading user input. Oh, I expected that part here to be much longer. If we want to interact with a user, we must be able to ask them for an input and then process it and use it. We need to read from a standard input, standard in, by passing standard in to the read line procedure. Okay, echo, please enter your name. And then we do let name and we'll assign it a read line and provide a stdin, standard input. So the type of name is inferred to be a string. Okay. And then we just echo hello name. Let's try it out. Let's see if it works. Let's see if Visual Studio Code says issues. Let's just go here. Save it. Yep. It inferred a string and we'll run it. Oh, please enter your name. Ben. See, code runner isn't that great. Run it again. Can't type in. That means we can go to terminal and do nim c-r and that'll be the hello.nim. Oh, nim. Enter our name. Ben. Enter. Hello, Ben. Nice to meet you. Awesome. That's simple. That is extremely simple. There are so many other program languages that just completely overcomplicated. I mean, there are reasons for making it more complicated, but I guess at this point here, there's no reason, and you could for sure make it probably a little bit more interesting on yourself if you dig deeper. Okay, if you're using an outdated version of VS Code, you cannot run this the usual way because output window doesn't allow user inputs. You need to run these examples in the terminal. The newer versions of VS Code, there is no such limitation. I have the newest version of VS Code, so okay. Dealing with numbers. Reading from a file or from a user input always gives a string as a result. If we would like to use numbers, we need to convert strings to numbers. We again use the string utils module. We again use the string utils module to use parse int to convert integers or parse float to convert into float. So we have this, please enter your year of birth. And your birth is, we read the line and we parse it as integer. Convert a string to an integer. Then written like this, we trust our user to give a valid integer. What will happen if user inputs 79 or 93? Try it yourself. Okay, let age, okay, you are that many years old. So it's a 6 years old tutorial. Why not? Something tells me few things changed in language since then. Probably minor things, but sure. So let's do 2024 and let's run it. Bam. Please enter your year of birth. I'll lie a little bit. Let's say a round number, right? Okay. So what if we're gonna give it none of your business? There we go. Parse_int, invalid integer, none of your business. Okay. So just throw an exception or error. Oh, unhandled exception. So it's an exception. Okay. Cool. If we have the numbers.txt in the same directory as our new code with the following content, and we want to read that file and find the sum and average of the numbers, provided we can do something like this. Yep, we can read the file, strip all the empty spaces, split it into lines, so we suddenly have, we import multiple modules. String utils give strip and strip lines. Sequence utils gives map and math gives sum. So we strip the final new line and split lines to create the sequence of strings. Then numbers is, okay, we take those numbers as strings and we map them where for each of them we're calling parse float, right? Map works by applying a procedure, in this case parse float, to each member of a container. In other words, we convert each string to a float, returning a new sequence of floats. Yep, so basically for each of those strings, it will call parse float. And then we do sum of the numbers is we call the sum from the math. So this actually takes the whole sequence and sums the whole sequence. That's handy. And average is sums divided by float of num length. Okay, just calculate the average. Okay, yeah, and of course this length is an integer, so we need to convert it to float first. Okay, very cool, simple. And I like to see the map. I wonder what else is in the sequence utilities. Exercises. Ask a user for their height and weight, calculate their BMI, report them the BMI value and category. We'll do everything from scratch. This way we'll learn something. Okay, so ask for their height. So we do echo, how tall are you, right? Then we'll at some point do how heavy are you? Guess what's your weight, whatever. And then we'll do convert strings to floats, because I will guess we'll be operating on floating values. Then will be calculate BMI, and there will be report the BMI value and the category. So it'll be something like echo your BMI is, we do BMI, and you're in category. I'll just print category. Okay, we save it and now we'll be complaining about not having those. So let's see how do we do read line, right? So we do the let height, and this will be read line, and it will be std input, and we'll just do parse float, right? But parse float was in something like string utils, import string utils. Yes, I remember correctly. Awesome. And then we do the same thing with weight. Okay, so we should get those two numbers. We already converted them to float. We don't care about errors. We don't know how to handle errors yet. And then calculate their BMI. Mass by height squared. Okay, so mass divided by height squared. Let's just do kilograms and meters for now, because that's the simplest. Let BMI is weight, and we divide it by height times height. I guess we can do import math, and we'll just do by height and this, right? That should be fun. Save it, and we have everything but the category. So the category is showing this thing. So that means that we need to get the case statement. Category, let category equals case BMI, and I don't remember off. Oh, now we can't do that because we're evaluating with larger, lesser, while case is only for simple things, so we can't do that. Okay, category will be error at first. Okay, so let's go from the largest to the smallest, or no, from smallest to largest. So if BMI is less than 16, category is underweight. Severe thinness. Okay. Why do we have errors? How can it be assigned? Of course. Var. There we go. And then else if BMI is less than what? 17. Because notice that this is from 16 to 16.9. This is from 17. So you know, I guess this is from 17 to nearly 18 and a half. And we, in the first if statement, covered everything from here. That means that here we don't have to check anymore because this wasn't smaller. That means it's only larger or equal of 16. So that's how we can just continue up. So if BMI is larger than, I mean below 17, category is underweight, moderate thinness. And then LF, and we can just copy this few more times, I presume. And this will be an other case, which is larger. So we just do else. Okay. We don't need the check anymore because if it's larger than that, larger or equal, we just go with that. All right. So that means we have the category, we can print it and can run it, right? How tall are you? And this is in meters. So let's say I'm 1.75. Okay. That sounds decent. So it didn't error. That means it parsed. How heavy are you? In kilograms, I don't know. Let's say I'm 100. BMI is 32.65. Just obese class 1. Look at that. Perfect. So that worked. If we'll go with some other crazy numbers, let's say 1.9. And let's say it's only 60 kilograms. You're very thin. Okay. Makes sense. Okay. So that exercise is finished. Now we have another callouts conjecture exercise. Repeat it. So our program asks a user for a starting number. Print the resulting sequence. Okay, so let's do it quickly. Let's get to the thingy again. That was in loops. Was first pick a number and do all those things. Okay, and we get back down here. Exercises. Cool. That means that we can, in our code, we can actually do a little fun thing and declare procedure. Calculate the sequence. I don't remember the name. And we'll return something. I just want to add it here so that I can keep track of what needs to be done. Okay, so we've got that. What was the whole exercise? It was basically, so program asks user for a starting number. So the exercise was that we need to print the whole thing, right? Print each step of the conjecture. Okay. That means in our exercise, we just print it and that's it. So we can make it return a sequence of numbers, right? So it'll return a sequence of integers. Well, we need to give it the starting number, which will be an integer. And the rules were first pick a number. We did that. If it's odd, multiply it by 3. So this is where we basically need to do the whole thing. So we'll just define ourselves a variable, which will be numbers, and that will be a sequence of integers. Okay. Hey, we actually don't need to do that because we have that secret result variable that's already defined by that, and it's empty because it's initialized. Wow, this is super awesome. So what we have to do is basically result add that starting number. Okay. This way we start with that, and then we can do while result, and we do last of the result. Last element of the result is not 1, then we'll just continue with the loop. So if, and we do the odd. If, let's get the let last number, that'll be the result. We'll just reuse that. So if last number mod 2 is 1, which is odd, then we basically do result.add, and we will add it. What do we need to do? Multiply it by 3. So last number times 3 plus 1. So we just do it like this. And else, if it's not, we just divide it by 2. So we do result add, it'll be last number divided by 2. We already went through that, and we just keep going. So that's it. So let's just do the result add. I wonder if that will work with all those little things. So add if this, we do that, else, and just do that. And it's not happy. Result.add. Go. Works. Wow, that's a short thing. And it already returns everything automatically. So we have the calculate. Then we can make another procedure. Print sequence. Oh, we don't worry about presentation right now. We already went over that once. So all we want to do here is ask the user, echo, pick a number, and magic. There you go. And and then we basically get the let starting number. That will be read line, standard input, and we want to do parse integer. So we need to do import string utils. There we go. So all we need to do now is let numbers equal, or we can just do echo calculate sequence, and we'll give it the starting number. Oh, we can't do that because we initialized this, and so we need to get full parentheses here, right? Or not. There we go. So when we run it, without that, sorry, this won't work. Go to terminal and we'll run it. Pick a number, 69. And there we go, the whole sequence. What was the number that was like large? 27. There you go. That's a large sequence. Cool, that works. And then we have one more exercise. Yep. Ask a user for a string they want to have reversed. Create a procedure which takes a string and returns a reversed version. For example, if user does this, returns that. Okay. Hint, use indexing and countdown. Yep. That's what I would do. So it just reverse a string and that's it. This will be really, really, really simple. We probably don't even... No, we need string utils to... No, we don't. Okay, so a word, please. And we'll get the word to be just read the line. Okay. Just in case, we're gonna strip it so that it's nice and without all the spaces. And they want us to make a procedure for that. So procedure reverse, and that will be the text will be just string, and we return a string. So how can we do that? So we already have the return value, which is an empty string, and it's modifiable, so we can just use that. So what we could do is a for index in, and we do now count down. We want to count down from, this will be the text length, -1 to 0 by 1, and this way we'll get indexes, so we can basically get 1 and just put it in a string, because we're going from the end to the newest. So result.add, and we do the text index, and that should be it. And then we just do echo, and we do the word.reverse. I really like the ways that we can just call all those however we want. It's just whatever makes sense, you call it that way. Here it was made sense to be clear that we add this. No parentheses, no nothing. It's so nice. Here we call the strip. We could call it like that, but because there's nothing, we can skip it, and just so nice and simple. Sure, it gives you room for decision, and then if you're dealing with other people, you might have some arguments, but if you define some kind of standard and have common sense, and you can get some consensus with some other people, then hey, it's awesome. So a word, please. Let's do a fun word. Shenanigans. I guess that's how you write it. Exclamation mark. Enter. It worked. Okay. Hey, first try. I'm impressed with the language. It's really fun. It gives you that room to enjoy it while it's still simple enough that, if somebody looks at the code, they won't have a headache. I'm sure you can make it look like a headache, but, if you have some brain, you can keep it simple, toned down, and yeah. Conclusion. It is time to conclude this tutorial. Hopefully this has been useful to you, and you managed to make your first steps in programming and/or the non-programming language. These have only been the basics, and we've only scratched the surface. But this should be enough to enable you to make simple programs and solve some simple tasks or puzzles. NIM has a lot more to offer, and hopefully you will continue to explore its possibilities. Okay, next steps can go with official NIM tutorial, NIM by example, there's Advent of Code, Project Euler. I don't like math.